Hi, everyone. I'm thrilled to see many curious minds in the audience. I think that after what we've heard this morning, you're all eager to know more about voice models, about how it works, and about how we put voice models into products. We will explore that. And to do this, I am joined by Alexandre Desfossés from Qtile, as well as Enrico Bertino from Indigo AI. We'll make our best to unpack this topic in the next 30 minutes. But first, let's get to know you a bit better. So, Alexandre, can you tell me who you are and what you do?
Yeah, thank you very much, Constance. So I'm Chief Exploration Officer at Qtile. Now I'm also, as it was recently announced, part of Gradium, so leading the science there. But I stay also at Qtile, so leading speech research. So I've been leading or co-leading a large part of the research around speech that we've been doing. So that includes the speech-to-speech model, like Moshi, eBiki for translation. Recently released TTS and speech-to-text models, and that's pretty much my life, like training speech and audio models with the great team at Qtile and now Gradium.
Thanks, Alexandre. Thank you very much. What about you, Enrico? Can you present yourself and tell us a bit more about Indigo AI?
Hi, everyone. I'm from Italy. I co-founded Indigo.ai 10 years ago. We started to do virtual assistants in an era where chatbots were not so sexy. So we started with NLP research and everything about intent classification, all the stuff right now. And we were very focused on make and take the models into production. And so we have enterprise clients, and we have the market in Italy, and we are leader in this part of conversational AI. We started with research and development at the beginning. In the BERT era, in the golden age of BERT, we did the most downloaded Italian BERT on Hugging Face. And fun fact, my surname is Bertino. In that moment, we made a distilled version of BERT in Italian. So it was the moment to name a model after me.
Oh, as you should. Thank you both for telling a bit more about yourself. I think it's time to dive in a little bit. So we've seen incredible demos today, this morning. Richie Mini, that was the white robot on stage. He was joking with Nell. He could be a she also, right? And I don't know about you, but I think this interaction was shockingly natural. Audio is definitely extremely exciting, but it's also complicated and fundamentally harder than text in AI systems. Can you give me your perspective on that, both of you?
Yeah, so it's been now a few years that I'm working around audio and speech, and I guess when I started during my PhD, I thought, okay, this is only going to take 1 year or something like that, and there's always something new to discover, and there's always something new to bring to get to the level of naturalness that we think, okay, that could be something, a conversation I have with a human. So I'm very happy that you found the interaction this morning supernatural. That's definitely the objective. What makes audio different from text is fundamentally if you take one person talking into a microphone, you record them for 1 hour, that's going to be like filling an entire compact disk, so 700 megabytes. If you take the transcript of what's being said into words, that's going to be like 50,000 times less information. Like text is language. It's something that evolves through tens of thousands of years to be a super compact, highly informative, and non-ambiguous way to convey information between human beings. Well, audio is messy. You can say the same thing, like what's the square root of 9 in a number of situations with a number of voices or intonation. And whether you're a man and you're currently currently in the mountain, or you're a woman and you're talking at a conference, the AI should always be able to understand the question, the same underlying question. So we have to handle all that diversity, and that's really interesting.
Okay. What about you, Enrico?
Yeah, we started doing only chat assistants, and in the last years we shifted a little bit toward the voice. At the beginning, we thought that voice was another channel, so a different channel from text, but we were wrong. Voice is another world, another ecosystem, and also the experience for the user is completely different. The text, you can read it twice, you can think about it. On the voice, if you skip one word, you miss all the content, all the meaning, and then there is latency, there are multi-turn taking, there are a lot of challenges completely different from the text version. So the human part is incredible, the empathy, but behind it, there is a very, very hard challenge to handle.
Let's focus a tiny bit on this human part. Voice carries many things, like emotion, tone, rhythm, hesitations. And this makes it a bit complicated to evaluate. So concretely today, how do you evaluate interaction, like voice interaction?
When we do a project with a client, the testing phase is the most challenging one. And I start with a story with a client. We made a voice bot. It was quite robust, quite ready to go in production. But the client tested it in a wrong moment and felt like that quality was not enough to go to production. So he started to say, let's start from the beginning. Let's do everything different. We only changed little configurations about the voices. We didn't touch at all the agents behind it. And the client tested it again and said, oh, that's perfect, incredible, we can go to production tomorrow. Because it was only about the mood and the feeling of the human, of the person in that moment testing the part. Because voice has this human part, human feeling, it is the subjective part, and it is very hard to evaluate. So also for us, we have automatic evaluation and testing of the agents, the flow, the content, the knowledge, but it's very, very difficult to automate the testing of the feeling and the human part.
Yeah, difficult to evaluate the subjectivity indeed. Is there any objective things you can evaluate though inside with concrete tools inside voice interaction?
So you can try to evaluate, for instance, word error rate, which is how many words were pronounced properly or how many words you transcribed properly, but that doesn't tell the whole story. If you just look at overall statistics and you see, okay, I'm only making 2% mistakes when I'm using my systems, the issue is where the mistake happens. Okay, if I tell you you have an appointment in a hospital on the 12th of December, but actually it was the 13th, maybe only one word is wrong, and that's going to completely ruin your experience. And so it's totally possible to have like those metrics very low, but still highly problematic. Then, as Enrico mentioned, there is a lot of subjectivity and potential psychological bias. So it's important to do studies on a large number of, we can try basically to objectify subjectivity by doing like statistical tests on a large sample of human listeners or human transcribers. And we try to, as much as possible, hide them. Okay, so we're not going to tell you that's the new version of the model. How does it do? Okay, we're just going to show them randomly the old version, the new version. Often people don't like too much change. I've seen with text-to-speech models. So if you say, oh, we have a new version, they're going to find issues that maybe were there before. But they're just looking for the issue because we just told them it's a new version. So we have to account for all that. A bit like it's almost like clinical trial in a way. Double-blind studies, and that's the kind of things we have to do to get the best performance.
Okay, got it. Thanks. And that was just the introduction, in fact. So for all the builders and the engineers in the room, I think we'll go a bit deeper inside the architecture system behind voice-to-voice, behind audio AI. Let's start with a kind of a trend. Everyone today seems eager to interact with AI agents, but does that mean that all agents will eventually become voice first? And if so, what does that imply for traditional user interface, UI?
Yeah, voice is very sexy, we can say, very cool to show because that's the human part, human feeling. But not every use case is suitable and requires the voice interface. When you have an information load, for example, a lot of information, data, visual to provide to user, it's better to have a text-based chat, a visual part, a multimodal approach. And so we are seeing that the voice application are perfect when you need fast information and you can access this information faster for the user. So for the user experience, very little information, but fast providing. And this changes also about the channel and the direction of the channel. So for example, if you are calling a user or a user is calling, then we'll speak later about it. Let's say that the use case changes a lot, the information you have to provide and the channel, the best channel to provide that information.
Okay. Any bet about UI?
So I guess on my side, I'm a bit biased because I've been working with speech for 8 years. I want it to be important. I want it to be the next big thing. But more and more often, although I'm more of a keyboard user, I guess I found myself in a situation where I'm like, it would be so much more convenient to use my voice right now to, I mean, even trigger things like relaunching an experiment or getting like information about like the experiments, model training that I've launched over the day. So I'm really excited to be building those tools. And of course, I don't think it's going to replace everything. A lot of the work we do is in open space. If everyone starts talking to their computer, it's going to be a mess. But I think there's a really nice area for improvement in this kind of UI and a gap to fill.
Okay. That doesn't fit any situation, right? But we'll talk about this a bit later indeed. Talking about architecture, it seems that two dominant architectures emerge today. So on one hand, you've got cascaded architecture. It starts with ASR, automatic speech recognition, until TTS, as you mentioned several times, so text to speech. And in between, you've got LLMs. And then the other architecture is native voice to voice. Let's have a look at this. Alexandre, can you walk us through the strengths and the weaknesses of both of these architecture?
Yes, so the easiest to understand, in a way, it's the cascaded one. From a technical point of view, we are just going to transcribe what the user is saying in a streaming fashion. So as they talk, maybe with a little bit of delay of 1 second, we convert it to words. Then we can easily give those words to an LLM. We tell it, okay, so the user said that, what should we reply? That can plug into anything that exists. So if you already have a text pipeline, we can just add voice on top of that. Maybe we need to do a bit of formatting, not output like huge tables or things like that. But it's super easy to use, and then the LLM outputs what it wants to be said to the user, and we synthesize it with a given voice. So for instance, the demo, if you saw the demo this morning with the Richie Mimi, that was what was happening. So we were plugged into a Qwen model. We also told the Qwen models, you can actually do function calling, so you're also connected to a robot, and if you say, okay, do the dance move to the robot, it's going to do the dance move. If you say, like, express sadness, it's going to make a sad animation. So it was super easy to add this function coding. It's really easy to add RAG, okay, so retrieval augmented generation. You have a database, and you want to look, for instance, for items that the user is asking about. The issue is that fundamentally you need to split conversation into turns. And sometimes that works. For instance, right now, the panel we're doing, it's very easy to separate into rounds, but now into turns. But now let's say you're having a conversation in a bar with friends on a topic that everyone has a strong opinion about. It's going to be completely different. Everyone's going to speak at the same time, cut each other, and that becomes almost impossible to handle because of the latency. Each time we need to think, okay, the turn is over, we need to transcribe, send to the text LLM. At best, in the good days, we get sub-second latency. But in some cases, if we are not sure that the user is done, or if the user is adding a bit at the end, like, yeah, sure, like this kind of short back channeling, this can get to a few seconds, and that becomes very bad. On the other hand, speech-to-speech model, which is the first thing we worked on at Qt because we believe that it's the future of human conversation, human-machine conversation. You can get latency down to 200 milliseconds, which is on par with humans. You don't need to split into turns. There can be overlap between the two, and so you get really the best naturalness. The issue is, for any new use case, you need to readapt the model. And let's say you're a big company and you just spent billions of dollars training your text model, and then you're like, oh, now I need to add speech. You kind of need to retrain everything. You need to retest that the model is as smart with speech than it is with text, and often it's not the case. Huge endeavor, and so in the end, I think the two are really interesting, but there's still evolution to do to speech to make it highly practical.
Enrico, how do you manage this to architecture today? And in 2026, where does cascaded still make sense, and where voice-to-voice is already winning?
Yes, for sure. In this moment, all the voice bot in production that we have are with the cascading approach, for sure. And sometimes we need this cascaded approach because for the thinking part, for example, in projects with a bank or an insurance, we need to call APIs to retrieve information of the user. We have to do RAG to retrieve knowledge. There are a very huge workflow to process to have the final answers. And it can take like 8 seconds, for example, if the APIs are not so fast. And so we handle it with some progress indicator, we call it. So the LLM starts saying, OK, I understood, let me check. So we reduce the latency with some UX tricks. And then we process asynchronously and in parallel all the pipeline. And so for this type of approach, I think also in the future, we can accept and we can use a cascading approach because we have control about the workflow and the agents in the middle, and they are very effective. And normally, this is the inbound customer support cases. So when the user has a question, needs an information, and also can wait a bit to have this information because normally the question is quite complex. And so it expects to have this information in some seconds. The opposite cases are the outbound use cases, when it's the voice bot calling the final users. And in that case, normally is the voice bot asking question, and the user has only to answer with information. In that case, it's very, very difficult to make good experiences with the cascading approach because there are multi-turn, very fast turn changing between the users and bot. If the user starts to interrupt the bot, it's very difficult to make multiple interruptions, multiple virgin. And so in that cases, we are testing right now the speech-to-speech approach, and it works perfectly because it's like low latency, very high rhythm in the conversation. That is what we need normally in a sales approach, lead qualification, and every outbound use case. In these cases, we think that the future is speech-to-speech. Also, the processing in these use cases is simpler because normally you need to ask information, retrieve data from the user, and then call some APIs at the end of the conversation. So you don't need all the pipelines for RAG, for example, and APIs. So it depends a lot on the use cases, and we will choose, based on the use case, which approach to use.
OK. If we still dig in a bit better on voice-to-voice, on speech-to-speech, it seems that speech-to-speech doesn't have this layer of explicit instruction as we so clearly explain in the workflow that works for Cascaded. This is good for preserving emotion and rhythm. So it's perfect. It's perfect for latency too. You just mentioned it. But what about steering those? What about steering voice-to-voice models? What safety and control challenges remained unsolved today on this part?
So that's a topic that we're actively working on at UTI. I think one of the vision that we have is basically to make kind of universal steerable speech-to-speech model that can be lightweight, and we're not going to pretend that it's going to have all the intelligence in the world, but it's basically able to, from time to time, on its own, ask for the help of like a bigger model. So it's like it has a joker, and it can ask the joker, like the friends. Actually, joker doesn't exist in English, I think. It's, I don't know. But, you know, the special card, not the evil in Batman. And the big model is going to reply, maybe do the RAG and everything, but during this whole time, and that's what you say with like, you know, the UX trick, but here it's going to be built in for the first principles. The model is always able to react to what the user is saying, it just knows that it's waiting for some more information, and it's going to hold on giving precise results until it has received that. So that gives a very nice ways to steer the model. We can also swap the model in the background, add more complex things. And this is also very nice because this small model could also run, for instance, on your phone locally. So that means if you have like a temporary loss of connectivity to the internet, you don't feel it while talking to the model. If you're still asking for very complex question, like what is the average number of sales over the last quarter, then you're not going to get it until you get back internet. But I think that opens up a lot of possibilities, and still research to do on that, but it's promising.
For example, internally we call it dummy agent, the dummy voice agent that only says to the user, okay, I understood, okay, let me check, okay, let's answer the basic question, but when you need the information, do the tooling part and retrieve everything. And it's very effective in the natural and the experience and user experience part.
Yeah, it's important for the user experience indeed. They need to understand everything's going all right.
It's like human, finally. Even there are human interaction where the human on the human operator does not have all the information to check, ask colleagues and so on. So it's very like human side.
Yeah, we're very sensitive to voice, so I mean, there's a lot of emotion. We need to be reassured a lot when seeing what's going on, that everything works fine. Another thing is that voice is very personal, with all the different accents there. I mean, this is a European event, so obviously we don't speak English all the same way. This is one thing. Accents are raising fairness challenge. So how do you manage this?
Yes, so it's a bit similar of how computers are now heavily used for every daily action. So you used to declare your taxes by sending some form through the post, and now you have to use a computer. So if you're like maybe your grandparents, they don't know as well how to use a computer, and it means they lose access to a number of public or commercial services. And with the rise of speech agent or this kind of speech product, I think it's very important to recognize that we want it to work for everyone, whatever is the background. So if you grew up in New York and you have like the perfect CNN-style American accent, everything is going to work for you. But we want it also to be usable whatever is your country of origin, cultural background, etc. Obviously, again, that's what I said earlier. We look at the world error rate. You know, you have 1% mistake, so you think it's okay, but maybe it's important. It's the same thing here. Maybe you have 1% mistake, but maybe it's specifically over, like for special, specific categories of people. So you want to be able to ensure like a good quality for everyone. And here, the things are a bit asymmetrical. So usually for text-to-speech, it's relatively easy. Also because like most people, they would understand, for instance, American English from CNN. So already for humans, it's asymmetrical. But if someone has a strong accent, or maybe speaking a dialect or something like that, that means that basically we need to find human annotators, like people transcribing the audio from all over the world. We need recording from those people, so we're going to work with voice actor or amateurs to collect those. And we really need the people from all over the world, because even for French, for instance, you could think that it's easy for a French to transcribe Quebec French, but it's not. So if you watch the show Empathy, which I recommend, it's very good. So it's from Montreal. If you don't have the subtitles, sometimes you just don't understand as a French. So we have to handle all those cases. So it's totally doable. Like humans are messy, but I think eventually we can kind of solve speech for everyone.
So you definitely doesn't look at it the same way from understanding and answering. Like these are two different challenges. What about really liability when you put it in production? Like any story you'd like to share about that?
Yes, for sure. Right now, the speech-to-text part is the most difficult to handle, because when we do normally a chatbot, the voice bot is multilingual, because in Europe there are a lot of languages, but also in Italy we have projects with European branches with different languages. We have projects in Switzerland where they speak. Everyone speaks 4 languages at the same time, and there is the limit in the speech-to-text because to have a good quality now, we need to know the language at the beginning of the conversation, and it's not so easy to handle a language switch inside the conversation. This changes completely with the voice voice approach, for sure, because it's like more free to handle all the languages at the same time as the large language model in the text-based. And for the text-to-speech part, we play a lot with accents in Italy. For example, we never use neutral accents, Italian accents, but we choose light accents. For example, our preferred are from Rome or from Sicily, because you directly understand that is something from that part of Italy, and this is more human. The feeling and the touch is less robotic, and so we prefer to choose with the client which are the best accent to use and to choose.
Who doesn't love arancini from Sicily? Okay, so now that we have only 3 minutes left, I'd like you, Enrico, to tell us a bit more about your experience when moving into productions. What are the bottlenecks that you faced? What are the understanding that you can share with the audience, all linked to implementation of this technology?
I think there are 2 big areas. The first one is about control. Let's say the LLM part, the speech-to-text, text-to-speech, it's only the visible part of the iceberg, but behind it there is everything about evaluation, guardrail, control, privacy, masking, and since we have enterprise clients, everything about compliance, privacy, and low latency, it's all about what we put behind this final part of cool interaction. And this is completely another world, because it's technical, but with different approaches, different skills, different products. The other area is the telephony part, because we did chat, text-based chatbot, and so the channel normally is a web chat in website front end, so this type of skills. With the telephony part is completely another world. We discovered everything about SIP integration, PBX, PSTN, this type of word that is like born 30 years ago. It's not so ready for the AI part. So, for example, internally, we had to build a team only about the configuration with the contact center, the telephony part, and so on. It is different type of profile skills and so on. So something that we didn't expect at the beginning, expecting it was only a different channel, but configuring and making sure that there is always the handover towards the human operator, for example, is not so easy to test, to validate, and to integrate.
Okay, thank you. So with less than 1 minute to finish this, if in one sentence you wanted to share what's the next big unlock is, what would that be?
Yeah, I think there's one that's very interesting and maybe not super technical, but I think for Europe, seeing all the innovation, all the new startups and everything, I think the next big unlock is to have something that's kind of sustainable in the sense like, long-range sustainability. It could mean profitability, but basically in Europe, we don't have Google, we don't have Meta, we don't have the big VC funds from the US, and we need, this happened before that France or Europe was in the race for technology, and now we're off to a very good start. And what's going to unlock the next generation of innovation is just to make sure that this stays possible. And diversity in the innovation and sustainability here in Europe.
Sustainability in voice, okay.
I totally agree. So the answer is the same. Another, the turning point that we'll have, in my opinion, is when we will have the latency on the user part and not on the AI part. And with the voice-to-voice, we are quite close to it.
Amazing. Thank you both for bringing so much clarity on the topic. Thank you, everyone, for being with us during this moment. We'll all be there the entire afternoon, I think. So if you've got questions, feel free to reach out.
Thank you.
Thank you, everyone.